Okay, so this is the summary worksheet in Chapter 8, and this is question number 7. And so a couple of things I did is, let's see if I can get a pointer going here. So the claim for this situation is that most cars occur within 5 miles of home. So most is the operative word here. I know this is about proportions because I don't see any means or standard deviations. And really, I have a categorical variable. It's yes, the car accident happened within 5 miles of home, or no, it didn't. So I know this is about proportions because of that. So there's my claim. So then I chose to use the, then I guess I should say my hypotheses. So the null hypothesis is no, the claim is not correct, that we can't say that more than 50% of the, remember, most car crashes would be if more than 50% of them occur within 5 miles of home. So the null hypothesis says, no, that's not true. We can't say that more than half occur within 5 miles of home. And then the alternative hypothesis, H1, is that yes, that's the claim. Okay, we said that those H1, HA or H1 said it's greater than a half. And then I've substituted in the sample result, and we see it's 0.52. So that's actually the point estimate if we want to think about it as far as a confidence interval. But this is asking us to do a significance test. So then the applet ran the test for us. Here's my test statistic. So that would be that solution there, 1.22. And then because we've got the p-value, we don't really have to go out and find a critical value. So this says the probability of getting a result, a sample result of 600 cars, where that proportion of the car accidents happened within 5 miles of home, is around 11% of the time we'll get a sample with that kind of result. So, which isn't really that unusual, right? If you think about using the 5% level, in fact, we're using the 5% level significance level. So the significance level is our acceptable level of risk. If we say yes, we're going to reject HO. If your p-value is less than that acceptable level of risk, you can say yes, we're going to reject HO. The data supports the claim. Because our p-value is much bigger than that, we can't reject HO. So we fail to reject the null hypothesis, in which case the data doesn't support the claim that most car crashes occur within 5 miles of home. In fact, if we use Dr. Stevens' terminology, which is really the same as that flow chart, I just don't have a copy of the flow chart right handy. Which I might stop this video and go find them. But let's see what Dr. Stevens uses, how he uses that phrasing. Then we can compare. Let's see, I'm almost there. You just wanted me to spend time with the video. Here we go. So the alternative hypothesis supported the claim. So that, remember that my HA was, my H1 was the claim. So we failed to reject the null hypothesis. So Dr. Stevens says there's not enough data to support the claim that most car crashes occur within 5 miles of home. Now, if we go find that flow chart, let's see, let me pause this recording and I'll come back. So then if I look at the flow chart that I provided you from Mario Traiola's textbook, did the original claim contain the condition of equality? In other words, was your claim HO? And it was not. Did we reject HO? Not. No. So then Mario Traiola says there is not sufficient sample evidence to support the claim that more than most car accidents occur within 5 miles of the house. So I almost like this terminology better because the data we collected doesn't support it. I don't know if collecting more data will change that result. I mean, a sample of 600 is a pretty big sample. So that's why it doesn't matter which you use. I mean, the big idea is we're not rejecting HO here. We fail to reject HO, and the reason is because the significance level is smaller than our p-value. Okay. Maybe what I should do too before I stop this video is let's go calculate the confidence interval for this situation here. Let me come back here and uncheck. Let's check confidence interval. Let's do a 95% confidence interval. Do you see how that 95% confidence interval captures 0.05 or 0.5? So because of that, that supports our decision that if we went out and used, so this says we're 95% confident the true proportion of accidents that happen within 5 miles of home is between 48.5% to 56.5%. That captures the 0.5 or the 50% figure. So we couldn't reject HO. I mean, it's entirely likely to go out and get a sample and have exactly half occur, or even less than half. So if this confidence interval hadn't captured the 0.5 mark, like what if I come back here and change this to, I don't know, what if we change it to 350? What does that do? Calculate. Yeah, so see how the way that changed now? If we had 350 or 58%, see how the confidence interval no longer catches the 0.5? So we would reject HO there because it doesn't capture the 50% number. And if we do the test of significance, I'm suspecting the p-value is going to be smaller than 0.5. And yeah, look at that. Z-score 4.0, p-value is essentially 0. Entirely unlikely, entirely unlikely to get a Z-score that far away from 0.5. 0.5 is the true center of this distribution. So in that case, the data would support the claim. P-value smaller than the level of significance. The confidence interval doesn't capture the hypothesized center. We could look at the critical value of Z and would see that it's more than Z in this case would be more than what is it? Probably 95%. So it's probably 1.645. I'd have to go look to see, and that's certainly bigger than 1.645. So hopefully this helps you make the decision without being too long.